In this video we will look at transformations on the modulus function. We're not going to use any new ideas or theories for this video, and a lot of it will be revision from earlier. We're just going to apply it to the modulus function. For example, plot the function f of x equals 2 modulus 3x plus 4 plus 5 under the transformation 2 f of 2x minus 1. Describe this transformation and use the minimum point as an example of how the transformation takes place. Well, first we need to find the points to draw this graph. And this problem is exactly the same as one we've just seen recently. So I will skip through this part and go on to the transformation part. What we should do first is take the 2 outside in the 2x minus 1. This means we need to translate it to the right by half of a unit, because in the innermost part we have minus a half. Then we need to contract along the x-axis by 2 units, since the next part is the 2, just one level outside the innermost part. And then moving out again, we see that we need to expand by 2 units along the y-axis in both directions. For example, the minimum point would be minus 4 over 3, 5, 2, minus 5 over 6, 5, 2, minus 5 over 12, 5, and again that will go to minus 5 over 12, 10. So that is where the new minimum point is. Here is the graph. Here's one I would like you to try. When you're ready to see the answer, please resume the video. So we need to plot this function, but now under the transformation minus 2 f of x plus 1. And as before, we'll describe, using the maximum point as an example, the transformation. Again, I won't show you how to find the points required to draw the graph, since this is identical to a recent problem. We can see the x plus 1 will result in translation along the x-axis to the left by 1 unit. Next we would double along the y-axis, because of the 2, and finish by flipping through the x-axis. In other words, turning the graph upside down. So for example, the turning point minus 1, 1 will get moved to minus 2, 1, which will get moved to minus 2, 2, which will get moved to minus 2, minus 2. And here is the graph of the transformed function. We'll just finish by saying a function is even if f of x equals f of minus x. And a function is odd if f of x equals minus f of minus x. So we can say that modulus x is an even function. Another example of an even function would be x squared and cos x. Examples of odd functions would be sin x and x cubed. That's all for this video.